So one another important example in a spring element is from the book of Logan. That is this is example 2.3. System is like that. This is a fixed wall. From fixed wall and a spring is connected. There is a rigid plate. This spring is connected to the rigid plate. A rigid plate moves in a roller support. This is a rigid body. So rigid body and remains vertical. So if it moves, it will move like completely in X direction. No bending, no oblique rotation will take place due to spring like this. So it remains transversely vertical. It remains transversely vertical, and another spring is connected here. Another spring is connected here. This again with a wall. This stiffness is different, and here a force of P is acting. So I'm trying to find what is the deflections at this point, because this is fixed. So deflection, nodal deflection will be 0. This is fixed. Nodal deflection will be 0. This is fixed. So nodal deflection will be 0. So this point will deflect. This point will deflect. This point will deflect. So finite element equation we have to develop. So let us say this way: the finite element model may be represented as may be represented as, I can write this is one element, stiffness is K1. So this is element 1 connected at node 1, connected at node 2. It has a node 1, so it has a deflection U1, it has a nodal force F1. It has a nodal deflection U2, it has a nodal force F2. Now there's another point here or here. If you see, these are the fixed point. So this point deflection, or this point can be taken as a one node 3. But element is connected something like that. You can think of a element, there is no connection here, but you can think of element 2, it is connected here. There is no element here. And another element is connected this way, this is element 3. So here it will U3 and F3. Another simplification I can write this way, okay, this is element 1 and this is point node 3, node 2, node 1. So whatever the way you want to represent mathematically or schematically is like that. So this will be a nodal force F1, nodal displacement E1, nodal displacement U2, nodal force will be F2, nodal force will be F3, nodal displacement U3. This is element 1, this is element 2, this is element 3. Element 2 is connected with between U2 and U3. Element 3 is also connected between U2 and U3. So what is the total degree of freedom? Total degree of freedom U1, U2, and U3, 3. This implies stiffness matrix will be 3 by 3. Stiffness matrix will be 3 by 3. Therefore, the finite element equation can be written as how? I can write it, okay, F1, F2, F3, this is nodal force F, and this will be 3 by 3 matrix, stiffness matrix, assembled stiffness matrix of whole system, and it will be U1, U2, and U3, right? So let us write it. So let us write it. So it is like that. It is like that. So F1, F2, and F3. And stiffness matrix will be 3 by 3. So I am going to write it U1, U2, and U3. So 1, 2, 3, 1, 2, 1, 2, 3 entry will be there. So representatively, I write it U1, U2, and U3. So what will come here itself between F1 and F2, U1 and U2 are connected. Between F1 and F2, U1 and U2 are connected. Stiffness of this element is K1. So I know if this is the K minus K and K, I can write it. Okay. Between 2 and 3, two elements are there. Element 2 connects U2 and U3. So let us first write for U2 and U3. Element 2. Element 2 connects F2, F3, U2, U3, U2, U3. So it will come at 1, 2, 3, 4 location. So this was K1, K1. Now stiffness of this matrix, this element is K2, this element is K3. So K2, add it, K2 minus K2 minus K2 and plus K2. What about element 3? It will again connecting between node 2 and node 3, that is connecting between U2 and U3, that is connecting between F2 and F3. So again here it will be K3, it will be minus K3, this will be minus K3, this will be plus K3. So if you little simplified version I am writing K1 minus K1, this is 0, rest will be 0. This is minus K1, this will be K1 plus K2 plus K3. This will be minus K2 minus K3. This will be minus K2 minus K3. This will be K2 plus K3. And U1 and U2, U1, U2, and U3. This is the finite element equation. Now apply boundary condition. Boundary means external boundary. So what are the boundary conditions given here? U1 will be 0, U1 will be 0, this is fixed. U2 will be 0, U2 will be 0. This U3 will be 0, this is the node 3. So U3 is 0, U1 is 0, and U3 is 0. Given force is P, means it is F2 is given, net resultant external force is P in the same direction. So F2 is P. Therefore, uh, this implies F1 is, and what is F1? Some reaction will come, that is still unknown. F2 is P. F3, some reaction will come, that has to be written, and that has to be found it out. So F1 will remain there, F2 is P, F3 will remain there because some reactions are coming, that is equal to K1. K1 is some value, so I will write K1 minus K1, this is 0, this is minus K1, this is K1 plus K2 plus K3, this is minus K2 minus K3, this is 0, this is minus K2 minus K3, this is K2 plus K3, and this part U1 is 0, U2 is the nodal displacement of node 2 has to be determined, and U3 is 0 because this U3 is the node which is connected with the fixed wall, and wall has no deflection. So this is 0. So This is the case. So how to, if you, this gives three equations. I have to solve it. So F1 equal to this into this plus this into this plus this into this. So let us write F1 equal to K1 into 0, 0 plus minus K1 into U2 plus 0 into 0. So this implies whatever F1 is coming, that will be minus K1 U2. Second, P equal to minus K into 0 plus K1 plus K2 plus K3 multiplied by U2, this into this plus this into this, it is 0. So this gives U2 is known now, that becomes P by K1 plus K2 plus K3. So U2 is now known. U2 is now known means this implies F1 equal to, from here, F1 equal to minus K times U2, meaning thereby minus K1 P by K1 plus K2 plus K3. This reaction force F1 is known. So this is now known. And F3, interested to know what is the reaction force F3. So F3 will be 0 into 0 plus this into U2 minus K2 plus K3 into U2, this into this plus this into this plus this into this plus 0. So this implies F3 is again minus K2 plus K3 multiplied by U2. U2 means P by K1 plus K2 plus K3. So the reaction force at the wall F3 is not now known. So this way we solve a combination of spring element joined through finite element method. So I know